Okay, page 2 of our Chapter 5 review packet. So just sketching a diagram to fit the description. In an isosceles triangle, the congruent sides are legs. The one that might not be the same is the base. Okay, so this time I'm going to do this one algebraically to get the interior angles. Okay, 68.5. And then 180 minus 68.5 would be our answer. This is a linear pair, so they're supplementary, and they add to 180. Okay, obtuse triangle cannot be isosceles is false. What you would do is start with any obtuse angle, and then the remaining two base angles will just split the remaining angle. So I'm going to start with an obtuse angle of 140. It's just a random choice. Just make sure you start with an obtuse angle. That leaves me with 40 degrees to split equally between these two base angles. Now, I avoided the sides. We should not include the sides because of trigonometry. Basically, if we were to state the sides and get one of them wrong, we would get the problem wrong. Okay, so let's avoid that on this chapter. We haven't learned that yet. So I crossed it off. I think I included it, but I did the trigonometry ahead of time. That's an estimation. That's rounded. But yeah, you'd have to get that perfect if you're going to include the sides, or else we really shouldn't be doing it. Okay, for the next one, the arrows are the markings that those are parallel. Arrows in the middle of what's shown. And I'm going to use corresponding angles. The 45 degrees here is also the same as the corresponding angle up on the other intersection, 45 degrees. So then you see these three together make a straight angle. So we will add those three to 180. I chose to do algebraically, but you could have just taken 74 plus 45 is 119, and then subtracted from 180 to get 61. Okay, so a coordinate geometry proof is slightly different than our typical proofs. So we're not going to have statements and reasons. We're going to make a calculation and then summarize it. Okay. Now, lengths that are equal tells us we have congruent sides. So we're going to calculate the length for isosceles. We really shouldn't talk about angle measures in coordinate geometry. Okay, we really don't know how to calculate them yet. Again, we trig, so it'd be much easier just to calculate lengths. So we'll just do that. 8 squared plus 5 squared, we're just using Pythagorean theorem. Instead of distance formula, we just use Pythagorean theorem. Now, I've had students ask me, why not just say, well, it's the same exact, change in y and change in x, just switch around. It's best to just show the calculation the way they expect it and take no risks there. So it's expecting calculations and then a summary. So let's give them what they're expecting. All right, they both come out square root of 89. Notice I did not round those. It's up to your teacher. I don't want my students to round them unless it says to in the problem, and this doesn't. So leave them a square root of 89. Now, we have AC is congruent to AT because their lengths are equal. And then to finish it, we have to finish by saying what we set out to. Triangle is isosceles. Okay, it's isosceles because it has two congruent sides. Okay, and that's it for page 2.